Hello, my name is Josh Obrecht, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Grassed Waterways Tool. This is the fifth tool in the Precision Conservation Siting Practices section of the ACPF Toolbox. Previously, you should have already ran the More Terrain Derivatives tool, as those outputs will be needed to run the Grassed Waterways tool. Grassed waterways are strips of perennial grass planted along areas of concentrated flow, and they really help with preventing gully formation and capturing some sediment before reaching the stream or ditch further downstream. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand Precision Conservation Practice Siting. Double-click the Grassed Waterways SPI threshold to open. This tool has 6 inputs that it's asking for, 2 of which are optional. The first is our field boundary feature class. The second input is the stream power index raster, which we produced when we ran the More Terrain Derivatives tool. When we ran that tool, we had the choice between a filled DEM or an unfilled DEM. The input help, which we can get by hovering over the red required asterisk, where it turns into a blue info button, goes over the differences between the two types again in case you needed a little refresher. We're going to talk about those types in a little bit more detail shortly. For your stream power index, you have a decision to make with the number of standard deviations above the mean to use as a threshold. 3 is the default value, but in the dropdown, we have a few options between 2 and 5 standard deviations. This threshold is the number of standard deviations above the mean the index is before a grass waterway is sited. The tool considers the mean of the entire stream power index raster. If you remember, these rasters actually expand to a 1,000-meter buffer beyond the watershed boundary, so these values can vary a little bit. It may not be as accurate as you're looking for. We will then need to add our stream reach feature class without the water bodies, and then optionally, you can also include water bodies and depressions. If either or both are included, no grass waterways will be included in the output if they intersect the included items. Before we run this, let's take a closer look at those specifications. As mentioned in the previous video for the More Terrain Derivatives tool, it really matters which DEM you use to generate the stream power index raster. Once again, here are the differences between using a filled or an unfilled DEM. In this example, using the filled DEM filled the depressions so flow was able to go right across them, where with the unfilled DEM, the flow path stopped at every depression. So just to reiterate, it is important to be aware of your inputs and the impacts they could have on siting conservation practices. Let's go ahead and run this tool. We'll choose our field boundary feature class from the first dropdown, since it's already in our map. The stream power index is automatically added into the next dropdown. For the standard deviation threshold, we will leave it at the default value of 3. Next, we have the stream reach, which was also auto-populated. The next 2 inputs are optional, water bodies and depressions. We will add our water bodies from the map, and we will also add our depressions, since we ran the More Terrain Derivatives tool with the filled DEM to get the stream power index. Our one output populated with the Grassed Waterway feature class. Click Run to run the tool. As the tool is running, let me give you a rundown on how it actually works. First, it's going to take qualifying SPI values, that's any value that's greater than the specified standard deviation, and those values are going to be smoothed with the majority filter. Whatever is remaining will then be expanded to improve overall connectivity. Then it's going to be thinned back down to 1 cell. Those remaining quote-unquote lines are then going to be converted to a polyline feature. Line features shorter than 50 meters are going to be deleted. This is just for practical purposes. Then a stream reach feature is going to be masked out. This is to make sure that we don't have any very long grass waterways being sited through channels. Finally, Only outputs within isAg equal to 1 field boundaries are kept. For this tool, pasture is excluded. The Grassed Waterways tool has just finished running, and the Grassed Waterways feature class has been added to our map. I've already increased the thickness to make it more visible. We have a few places along the landscape, including some long ones, which is a good thing. We'll zoom in to take a closer look. If we look at them with the hill shade, these grass waterways are placed in the lower areas at the bottom of slopes, which makes sense. Let's take a look at our attribute table by right-clicking on the Grassed Waterways feature class in the table of contents and clicking Attribute Table. The only values are the field boundary ID and the length. You may be asking yourself, wouldn't some of these grass waterways cross a field boundary? We'll turn on the field boundaries and zoom into an area where the grass waterway crosses the field boundary. Click on the Select button and select the grass waterway. By selecting the grass waterway, it shows they've actually been split up by the field boundary. These are two separate features. This allows us to look at how many are cited per field. A nifty thing you can do with your grass waterway output is prioritize it by runoff risk assessment. In the grass waterway attribute table, we have our field boundary ID, which means that we can join our runoff risk assessment table to our grass waterway output. To perform the join, right-click on the grass waterway feature class, go to Joins and Relates, and click Add Join. Our grass waterway feature class will auto-populate as the input table. The runoff risk table shows as the join table since it's the only one that's currently in our map. For input field, we will choose our field boundary ID. Since the runoff risk table has the same field, ArcGIS Pro recognizes that the field exists, and we'll set that as the join field. Let's hit OK at the bottom of the Add Join window. Select our grass waterways in the table of contents on the left, and click the Symbology tab in the right panel to open the Symbology window. From the drop-down under Primary Symbology, click Unique Values. We'll be visualizing on the runoff risk rank field, so we will select that field from the field dropdown. Let's right-click on the null value in our classes and click Remove, because we will not need to visualize that. And under the Color Scheme dropdown, we will choose Red, Blue for classes. We can now get an idea of the priority of these grass waterways, where they may be most effective. The red ones, for instance, may be more helpful with preventing gully formation and other erosive characteristics compared to the ones in blue. This is just a different way to visualize and assess the output. To recap, we ran the Grassed Waterways tool and discussed how we can determine what thresholds to use as inputs. In the next video, we will begin the next tool in the Precision Conservation Practice Citing section, Contour Buffer Strips.